Hello, it's nice to be here. I prepared such slide, but I believe it's not needed anymore. But maybe it's worth to mention that all that role that Eva said, this is in a single project. It's in KMD elements. DevOps. Over the last few years, DevOps definition and understanding changed, evolved, and I believe there is no single sentence that can describe what actually DevOps is. But for this presentation, let's define DevOps as culture of work with one single and main principle: you build it, you run it. And with that in mind, let's imagine we are not developers, but we are building a car. Our team is responsible for building a car. So as a team, we must build our own engine, we must prepare our own tires, we must put everything together and then deliver to the customer. And as you for sure understand, building cars is quite complex. You need to understand metallurgy, you need to understand how to mix alloys, you need to understand electricity and much, much, much more. And to bring everything together, it needs a lot of knowledge in your head. And in general, it produces some cognitive overload on you. So you have to maintain a lot of knowledge from different disciplines. And actually, it's not directly connected to the way to your responsibilities. It's not connected to your passion and so on. But you still have to keep it in mind. Then maybe in some companies we have more than one teams, and each team is building their own cars. So we have one, and as usual, cooperation between such teams. It's, let's say, not perfect. So each team is working on their own solution, on their own concept, and knowledge is not propagated across organization. And with such situation, we are constantly reinventing the wheel. And because of that, we are losing money, we are losing time, we are losing people because they are not doing the stuff that they are hired, but they have to know a lot about whole setup. They have to constantly repeat yourself, and it's just boring. As Ala and Eva said before, Element started more than 3 years ago. We started with 3 teams, and at the beginning we had monolith with few satellites, let's say around 5 applications. 3 teams, 5 applications, and each deployment of new application took around 10 days. And in that scale, it was acceptable because we had just few applications. But when our setup was growing, when we had 7 teams and around 23 applications, and we started our microservices journey, that cost was not acceptable. Because in the future, for sure, we would like to create more services because our number of the domains was growing. Still spending 10 man days, so it means that one person works for whole sprint on deployment of new service. It's totally unacceptable. It was bad. We had some conversation with management, such conversation. No tears, but still not pleasant one. And we had to do something. First of all, we checked our DevOps approach, if it's correct, if we are doing everything by the book. But it was not fault of the DevOps. It was not fault of our approach. Actually, it was fault of our scale. Because when we started small, then some activities that we done, like this reinventing the wheel or this cognitive overload, it was not visible because we are doing this not too often, quite rarely, with just few services. But when the scale was growing, when the new teams arrived, such issues were more and more serious. So because of that, we are looking for solutions of that issues. We are checking of some extensions of the DevOps approach that can help us and save time, save money, save people because we like to work with our developers. And we found out that there is quite interesting new movement, which is called internal developer platform, which is kind of extension of the DevOps approach and the way how we can efficiently work in DevOps setup and efficiently work with growing setup. So in general, let's split internal developer platform definition into 3 pieces. So first of all, IDP, internal developer platform, is some of all the tech and tools that platform engineering team binds together to path golden paths for developers. Here we have first highlighted term, which is a kind of building block for the platform engineering. Golden path is set of the templates, set of the scripts. For instance, it can be microservice template, it can be repository template, it can be platform, it can be pipeline template. So all such tool that which allows us to not repeat yourself. Just take it, parameterize it, and use it. One remark: golden path. It's term designed by Spotify. There's also other term like path. I don't remember, but similar term provided also by the Netflix. Okay, let's move on. The second part of the definition, IDP lower cognitive load across the engineering organization and enable developer self-service without abstracting away context from developers or making the underlying tech inaccessible. Yeah, so as I mentioned, cognitive overload is something that is very common in DevOps setup, and this is also something that we would like to avoid because this is a waste of money. So with our platform, we would like to make our developers' life easier, so they can focus on the business, not on the DevOps world, not on the infrastructure, because in general, this is something not interesting for them. They are doing this, but in most cases, they don't like it, or maybe they are changing sometimes work because they're forced to do this. And also, other term that is not highlighted, but also is very important, it's self-service. Because we are constantly growing, we as organization, but also other organizations that are using platforms, they're also constantly growing. The self-service part is also very important because it allows developers to do anything on their own. So they can create new application, deploy it, maintain it, monitor, and everything by themselves with the tools provided by the platform. And because of that, their life is easier, they are more efficient, they can spend more time on business activities. And also the third part of the definition, well-designed IDP follow a platform as a product approach, where a platform team builds, maintains, and continuously improves the IDP, following product management principle and best practices. What's important? As I mentioned, we would like to make our developers' life easier. So first of all, we must talk to them. We must understand their point of view. We must understand what are their needs and what issues they are struggling. When we understand their world, we can provide something, some mechanisms that can make their life easier. But of course, after some time, we need feedback for them. And all that parts, when we collect them, it's called exactly product management. So this approach, we have just, with this approach, the way how we are working with our platform is actually established and well-defined. So we don't have to reinvent some stuff that other companies already done. And because we are working with our platform as a product, it's very important to have appropriate person as a product owner. Platform is not regular product, so you can't take just first business product owner and say, from this day you are platform product owner, enjoy it, and this is your team, of course. In general, platform it's very technical stuff. So you have to you need person that understand developers' need, the person that knows how to communicate with developers. He must understand his knowledge, his language. So in general, in most cases, this person is some kind is architect or at least some senior engineer. Like, well, in our case, it's architect. You know. And of course, such product owner also must work as regular product owner. So he's responsible for vision of the product, but this vision must be aligned with the needs of the customer, of the developers. And also he's responsible for prioritizing backlog. And here, fun fact, developers would like to have everything right now. Not tomorrow, no, in 5 minutes, right now. I'm just raising requests, where's my functionality? So this prioritization and cooperation with developers is quite important. Maybe a few words about how we built our internal developer platform and what kind of issues it solves. But before that, I believe once again, a few words about our about Elements, but this time from technical point of view. So Elements is time series based billing engine. There's one sentence. It means that we are collecting overwhelming amount of time series data, processing them, and in the end, we are saying how much money should pay that party to another party. Soon we will process, we will store 10 terabytes time series data in many different storages that we have in the platform. And soon we'll have to ingest data for around 10,000 meters per minute. When I'm talking about meters, it's about meters that you have at your home. Those meters are sending data to electricity company, and then electricity company is sending those data to our system. So it's quite challenging. We need significant performance to handle this and so on, but this is not so important. Once again, about our setup. Right now we have 11 teams and we have 69 microservices, and that number is still growing. We are still discovering new domains. We are still delivering new services, new BFFs, new frontends, and so on. Everything in micro approach. So this deployment part is really important for us because if we will spend 10 days for each service, I believe most of our developers just sit and type some pipes. Yeah, we have 25 environments split into 5 stages. So it's into dev test stage and production. On each stage, we have one Kubernetes cluster. And right now we are doing 80 deployments per day for int, dev, and test environment. So as you see, having or maintaining this DevOps part of our project, it's quite important. Yeah, so 1 year ago, all our applications was deployed on PaaS services, on Azure PaaS service. We are using Azure Functions, Azure web applications, and the amount of flexibility that those platforms delivered was not enough. So first decision, we need something that is more flexible, that allows us to easily deploy new application faster with some additional strategies. And then we decided that we'll use Kubernetes. And because we are using Azure, we are using Azure Kubernetes services. The biggest benefit of Kubernetes is the way how it manages state. Actually, you are just providing expected state to the Kubernetes, and Kubernetes and all the operators and controllers working there, they are just aligning state of the cluster to your requirements. Then we must somehow build our application and deploy it. So for building and release process management, we are using Azure DevOps. We have dedicated pipes for that. But continuous delivery part, for continuous delivery, we are using Argo CD. Tool is totally magical. First of all, it's GitOps tool. So we are storing desired state of the application in Git, and we have all the policies applied on our Git repository. So we have pull requests, we have list of the approvals, and so on. Deployment windows for test environment. Everything is based on our Git repository. And then there's Argo CD that is consuming our repository. It's generating all the Helm charts, all the Kubernetes manifests, and applying it on the Kubernetes. The difference between Argo and other solution of this kind, it's wonderful UI. Of course, you can use console application like with other tools, but let's say it's much easier to just click in the web browser, choose appropriate pod, check the state of the pod, check configuration of the pod, and you can do this in just a few clicks. You don't have to remember all the command line. Additionally, on the dev environments, developers can check logs of the application just using UI. They also with just few clicks. If they need to align some configuration and check how this new configuration works on the environment, they can also do this from the UI. Then they can copy this configuration to the repository and follow the regular process. So this is kind of foundation of our platform, and the most important piece that exists in our Kubernetes cluster. Service mesh. As I mentioned, we have microservices. Microservices are very chatty. And there is one requirement that is very common in all the sectors. All communication must be encrypted. And if you ever created some certificates and had to manage it, it's quite a significant issue because you must establish your own certificate authority. Your application must be ready for some certificates renewal, so it's quite challenging. And Istio gives you this out of the box. You are just deploying it, enabling it, and it's working. And it gives you a few additional benefits like wonderful observability. You saw already Zipkin on one of the first presentations. So all the spans can be exported to the Zipkin, but also gives Istio out of the box, give you wonderful metrics that can be checked with Grafana. Also, Istio is deployed together with some basic alerts that can be customized and assigned and aligned with your setup. Monitoring, no-brainer here. Just Prometheus as a pack of kubeprometheus stack. So it's deployed together with Grafana and Alert Manager, nothing fancy. And data storages, here another funny part starts. We are using Azure SQL Server, no brainer here. We are using Azure, there is SQL Server, we are using it. But for the Redis, we decided to use to deploy this on Kubernetes cluster. We are using Bitnami Helm charts for this. Well, nothing fancy, but Elasticsearch is something fancy. Yeah. So you know there is bunch of the Helm charts or bunch of the YAML definitions that you can just use to deploy Elasticsearch. But Elastic Company delivered a dedicated operator that allows you to easily deploy and maintain Elasticsearch on your Kubernetes cluster. Operator's name is Elastic Cloud on Kubernetes, and it's defined and it allows you to create your own dedicated objects called Elasticsearch and Kibana, and define all the properties, all the configuration as a part of these objects. You are just sending this object to the Kubernetes, and then Elasticsearch operator, it's creating Elasticsearch, it's creating Kibana, it's creating all the certificates for the communication. Whenever you would like to change version of the Elastic, you are just changing one attribute in the YAML, and then magic happens. Operator just restarts all the nodes in the appropriate order. So the cluster is available all the time to the user. So it's very simplifying all the administrative work around Elasticsearch. So our platform engineers have more time on other activities than just watching Elasticsearch. As I said, we have microservice-based architecture, and for sure you know there's no real microservice architecture without message broker. Ha ha ha. But yeah, we need message broker because we are processing overwhelming amount of data, especially those meter readings, and we decided to use Kafka because of the well-known performance, well-known scalability. And of course, there is a lot of way to deploy Kafka on the Kubernetes cluster. We decided to use streams operator. Once again, it's operator, and streamz simplifies the way how our platform team members interacts with Kafka, and it lowers all the maintenance requirements. So for instance, if you need to reconfigure Kafka, then you are just changing Kafka object, and then streams operator during reconciliation process, it's changing some configuration in the runtime if it's possible. If it's not possible, then streams operator is trying to restart all the nodes of the Kafka in the order that will not break anything. So Kafka will be still operational and available to the user. And this is our abstraction. Yeah, it looks really abstract, but in general, we followed all that rule that I mentioned. So we prepared, we have my template for the microservice. We have template for Azure pipelines. So each time developer would like to deploy new microservice, he has set of the templates for that. When he have application, then he has to create pipelines in Azure DevOps using templates. After that, he's cloning our Helm chart repository, and he's registering his microservice there. And of course, he's providing also configuration file. This is part of our values file, the most important part where the services are registered. So we have microservice object. There we have, for each microservice, we have name. For this example, we have central address register API. For each service, we have owner. So when application is failing, we know which team is responsible for that. We have type of the service. Right now, we are supporting only .NET, but in the future, I believe we will support also other technologies like Python, maybe. Image that must be deployed on the Kubernetes. How many applications, how many instances of the applications should be deployed. There's also option to set max number of such replicas. By default, it's 10. Then let's skip migrations for now. And then we have infrastructure part. And in that part, developer describes what kind of infrastructure is needed to deploy this application. So in this example, we see that SQL Server is required. And also we have here information where connection string should be saved when database is created. We have information that Kafka is required for this service. Also, we see that this application would like to produce some messages on the topic. There's also a section for consuming. Basic on that list, we are creating access control list. So we can easily block some applications for consuming events that should not be consumed by this application. We have also two other sections that are not visible here. Developer can define that Redis is required for this application, also declaratively, and can set up communication with Elasticsearch, also using YAML syntax. And let's go back to the migrations. We have here situation that application requires a database. So in most cases, application would like to have some structure inside database. So developer can define some migrations that must be executed just after the database is created, but before the application is deployed. Yeah, so in such, so our platform delivers set of the tools, set of the templates, set of the abstractions that allows developer to easily deploy application. And comparing to the car, to the scenario that we are building a car, developers still have possibility to log into the Kubernetes cluster, have possibility to log into the Argo, look at the objects that are created on the cluster, and also they have possibility to interact with these objects. Some conclusions. Pure DevOps doesn't work in big scale. So you need something that will help you when you are growing. It can be, you can choose many different solutions. We chosen platform engineering as the one most promising. Yeah, so it also solves our issues like cognitive overload and constantly repeating ourselves. When you decide to build your own platform, just use proper tools. So first of all, you must understand your needs, you must understand your use cases. If you are not sure what will be the best tool, but you see that you need this kind of tool, just follow some easy decisions, check some technology radar, and this will help you make decision. Create proper abstraction, because this is something that must be very carefully prepared, because this is something that it's hardest to change in the future, because it's living organism after we give it to the developers. GitOps and Kubernetes operators really simplifies your need and allows for creation almost every abstraction that you imagine. And actually the most important, start small. So first of all, go to your developers, ask questions, ask what is the biggest pain in their daily work related to application lifecycle. Deliver first part of your future platform, and then take feedback and repeat. So it's iterative approach. You must constantly ask your developers about their feeling and about their needs. Oh, sorry. Not mine. Okay, any questions?
Just one question from me. So I would like to ask about this term, internal developer platform. Is it something you invented in Elements, or is it some industry term you adopted?
No, it's industry term. There is also platform engineering as a stream in computer science. It's growing, still growing. So there's also a lot of materials in the internet. There is a wonderful book about Teams topologies, which also describe some part of this, maybe not platform itself, but platform team, some real valuable member of the setup.
Okay, thank you.
Okay, thank you, Roman. Any other questions? Looking for hands. Do you have hands? Okay, no hands raised. So thank you, Roman, again.
Thank you very much.